2.1 is about describing the location in a distribution. So we will be looking at percentiles and z-score. So let's identify the location for percentiles. So the pth percentile of a distribution is the value with p% of the operation at or below it. If Jenny is in a class of 25 students and makes an 86 on her test, she has the fourth highest score. Is her percentile the same as the percent correct? So let's figure out where she's at. So there are 25 students. She's the fourth highest. So we're going to count down 25, 24, 23, 22. So she is the 22nd out of 25th. So she scored higher than 88% of her peers of the class. So Jenny is at the 88th percentile. Let's look more at percentiles. So wins in Major League Baseball. The stem plot shows the number of wins for each of the 30 Major League Baseball teams in 2009. So we see the 5-9 represents 59 wins. So calculate and interpret their percentile for the Colorado Rockies, who had 92 wins. So let's find out where 92 is. It's right there. So we're going to go backwards, and there are 30. So 30, 29, 28, 27, 26, 25. So it's 25 out of 30. We go ahead and calculate that, 0.83. So the Colorado Rockies are in the 83rd percentile. Okay, New York Yankees, 103. They are the highest score. So we would write that as 30 out of 30, which is 1. So that is the 100th percentile. So they got 100% more. No, they were higher than 100% of the other teams. There we go. So the Yankees, who won 103 wins, is at the 100th percentile. Cleveland Indians, 65. So we're going to go to 65, but there's actually 2 there. So we could do 30 minus 1, 2, 3, 4, 5. Or actually, it's just 5 instead of going backwards. So it's 5 out of the 30. So I can't say 4 because both of those are the same. They're both at 65. So 5 out of 30 is 0.17, which is the 17th percentile. So the Cleveland Indians, it would be 65 wins at or below 65 wins. So that's why we had to go both of them. We had to go to the furthest one because the first 5 is at. It's not below. The second 5 is also at. So we had to go to 5. Okay, let's look at median household incomes. So this is called a cumulative relative frequency graph, or ogive. It shows the distribution of median household incomes for the 50 states and the District of Columbia. So let's look at California. California has a median household income of $57,445. Is at what percentile? And interpret this value. So we're going to go to our household income, go to about 57.5. Okay, so that's right there. So then you go up and you find out where it is on our graph. Then you go over to find out the percentile. So it looks like it's at the 80th percentile. Okay, the next one, it says, what is the 25th percentile for this distribution? So now you start on the y-axis. You find out where 25% is. Then you go over to the graph. Then you go down to find out what the household income is. So it's about $45,000. And the 25th percentile is also called Q1 because remember, quartiles are your quarters. So 25th percentile. Okay, let's talk about the shape from ogive. So we're going to look at the steepness. Okay, so skewed right is where your steepest values in the lower values. So it says, where is the original graph the steepest? So let's go ahead and circle that. That is where it's steepest. And then what does this indicate about the distribution? So the steepest part is between 40,000 and 55,000, representing between 5 and 75% of the data. Because if you go over to the y-axis, you see that at 40,000, it's at about 5%. And then up at 55,000, it's probably about 75%. So this is slightly skewed right. The remaining 25% is in the tail. So skewed right means the steepest is in the lower values. Skewed left, steepest is in the higher values. So go ahead and draw that. And then symmetric, steepest is in the center. So you're looking again at the tail. Where is the tail located? Okay, let's talk about Z-scores now. We're going to see Z-scores a lot. So Macy, a 3-year-old female, is 100 centimeters tall. Brody, her 12-year-old brother, is 158 centimeters tall. Obviously, Brody is taller than Macy, but who is taller, relatively speaking? So in relation to each other and in relation to the same age group females, same age group males. So relative in the same age, who is taller? According to CDC, NP, of the height of 3-year-old females have a mean of 94.5 centimeters and standard deviation of 4 centimeters. The mean height for 12-year-olds is 149 centimeters with the standard deviation of 8. So we are going to look at each one, compare it to the average girl. So let's look at Macy. So Macy is 100 centimeters. The mean is 94.5 centimeters. So we subtract those. So she is 5.5 centimeters above the average girl. Okay, and then Brody, 158 centimeters compared to the mean of 149. So he's 9 centimeters above the average boy. So right now, it's hard to compare each other because it's not standardized. So what we're going to use is that standard deviation. So we need to consider the typical deviation from the mean. Typical deviation is how far away from the mean it is. So we would look at standard deviation. So Macy is 5.5 centimeters above the average girl, but our standard deviation is 4. So we're going to divide. So this is 1.375 standard deviations from the average height of girls. And we're going to do the same thing with her brother, Brody. He is 9 centimeters above average or above the mean, and then standard deviation is 8. So we're going to divide by how much standard deviation is. So it's 1.125 standard deviations from average height of boys. So which one has a higher, it's called a Z-score, is Macy. So we can see that Macy is taller than Brody at her age and compared to females. So these are called Z-scores. So the Z-score tells us how many standard deviations from the mean an observation falls and the direction. So here's our formula. Z equals xi minus x bar over s of x. So remember, xi is the data or the observation, x bar is the mean, and then s of x is our standard deviation. Our unit will be standard deviations. So it's not going to be like centimeters. It's 1.375 standard deviations. That's our unit. Positive Z-score means it's above the mean, so it's higher. Negative Z-score tells us it's below. So that's what it talks about where we have direction. Above is positive, negative is below. Okay, so let's talk about our home run kings. So we have this information. So go ahead and read that information. You can pause it to read it. Okay, we want to find the Z-score for each one so we can compare. So let's talk about Babe Ruth first. He had 60 home runs. The mean was 7.2. Wow, that's a big difference. Standard deviation is 9.7. So we are going to use that formula. Let's go ahead and identify what the parts of the formula are. Xi is our observation. X bar is our mean. S sub x is our standard deviation. So we're going to do our observation minus the mean over standard deviation. So for Babe Ruth, it's 60 minus 7.2 over 9.7. So it's 5.44 standard deviations. Okay, we're going to do that for each one. So here's Morris. So 61 minus 18.8 over 13.4. Remember, we're getting this from our table. So that one's 3.15 standard deviation, 3.15. McGuire, we got to do mean, observation minus mean over standard deviation. We get 3.88. And Bonds, we're going to do same thing, 73 minus 21.4 over 13.2. We get 3.91. So remember, you can pause these videos if I'm going too fast. So now we have to compare. So Babe Ruth's Z-score was 5.44. So how does that compare to everyone else's? All players are above the mean for their respective years. It's true. However, Babe Ruth is the home run champ, relatively speaking. That's how we would summarize that. That's how we would compare. Okay, so let's look at our final example. In 2001, Arizona Diamondback Mark Grace's home run total had a standardized score, aka Z-score, of Z equals negative 0.48. Interpret this value and calculate the number of home run hits. So, standard deviation is 0.48, and it's below the mean, so we know it's going to be a negative. We know the mean for, let's say, what year was this? 2001. So we got to look at the table from above. And we're going to use our formula. So we know the Z. So Z is negative 0.48. And then the numerator is going to be X. I don't know what X is. I don't know what he got for home runs. But I know the mean for that year, and I know the standard deviation. So then what do we have here? We have an equation that we must solve. So following the rules for solving equations, we would multiply both sides by 13.2. And we get negative 6.336 equals x minus 21.4. And then we're still solving for x, so we add 21.4 to both sides. When you do that, you get approximately 15. So Grace hit about 15 home runs. Okay, that is it for today's notes.